All right. So I'm going to solve the problem of why there's anything at all. Um, so we know that there's matter and antimatter, and we know that in the beginning of the universe there was lots of energy, and this matter and antimatter should have annihilated each other, right? But it didn't because and um you know, we feel that this antimatter should react or act exactly how matter does, but I don't think that that assumption is correct, because yes, everything is the exact opposite, right? But for that exact reason, things shouldn't work, because if matter we observe can create complex matter, right? And create the universe we live in, antimatter should not be capable of that as just a function of being opposite, right? So if you imagine it like this, we have a single proton, right? And then we have regular neutrons, and we've got an electron, right? This proton gets an electron, and it's chilling, and then it brings in some neutrons, and because there's lots of energy, it has lots of energy, it pulls in neutrons. These neutrons become protons, and maybe other protons join in, and creates more electrons. And this in this high energy of the beginning of the universe, right, we get the formation of basically helium. And when you honestly, I don't even know if you need to go that far now that I'm thinking about it, but we can get the formation of helium, right? And as I've said, basically this helium has more mass than hydrogen, and more mass is also more energy. Because it has more mass, it's getting a higher energy flow. And I didn't really understand the mechanism of how that really made sense. But I think in the last video I kind of answered that for myself, which is why I'm doing these videos, because I would have never come to that conclusion without talking about this like this. And it's so crazy. But basically, the more mass you have, the more energy you can create. And so antimatter still has mass, right? But it just has the opposite properties. But the problem is that if it is the opposite, right, then it still has mass, but its energy will if this one's increasing its mass, increasing its energy, this one is the same mass, right? But it's also increasing its energy. It's not that it's like, if you think about this with charges, right? If the proton is positively charged and the antiproton, I can't think of what the term is if that's not what it is negatively charged, right? Increasing the mass of this negatively charged proton or antiproton is not going to increase its negative charge, because, like I said, charge is just lack and gain, or excess and lack. And so this antiproton, as it either increases in mass or gets more energy, it's getting that that lack satisfied. So when they collide and they're supposed to annihilate each other, what ends up happening is that this one is no longer equal to this one. This one is much greater And this one has, like, instead of it being -1 and 1, this is more. Camera died. Instead of it being negative, I guess it doesn't matter, -1 and 1, right? This one has now become like, I don't know, -1/10, right? And this one has become +2, right? So when this one smacks into this one, it's like, what was that? Like, nothing happened, because this one has so much energy still, and so this one is supposed to be the opposite of it. But when it hits it, it cancels out whatever that opposite is still, but this one is still, it still has plenty, right? So the reason why there's matter and there's anything is because initially when they are created, they are equal, but since there's excess energy around, this one and this one no longer stay equal. This one heads towards neutrality, and this one heads towards an increased positivity. And if you think about this on the neutrons, right? Like if you add neutron, like this one, maybe say this one forms like more neutrons, right? This is heading towards neutrality. And the problem with that is that as this heads towards neutrality, right? The positrons that are orbiting around this are what have to provide the energy for this anti-atom, right? But the problem with that is that, one, the positrons are a tinier mass, right? So their flow is lower, and two, neutrons don't bind to the positrons. They bind to the anti protons. So these positrons never increase the amount of energy they output, and therefore cannot sustain higher mass nuclei, because an increase in mass requires an increase in energy, like flowing through the atom. But it can't flow. It's not a self-sustaining, self-building system, because as a core concept of being opposite, it does not have the same capabilities as like normal matter. Protons and neutrons and electrons, they by definition have to create, and this one by definition cannot, because they're opposites. So, it seems weird that, we have these annihilations happening and that they should just cancel out. But if there's enough energy there, right, to change the system and create an imbalance, then we no longer get this weird, why is there matter? It seems obvious that there should be matter, because they're not equal. And now, we see annihilations happening because there's not all this excess energy that is causing, like we see when an electron and a proton hit each other, they annihilate, right? And we don't see a lot of antimatter forming, because it's just getting annihilated by the overwhelming amount of regular matter that's here now. So it doesn't even have a chance, even though the energy state is lowered. At this point, normal matter has gotten such an upper hand on things that antimatter just doesn't stand a chance. And that's pretty much why the universe exists, because there wasn't a balance. And another thing too is, I think I'll talk about it here, is when protons get greater amounts of energy, something that I found out in a video I didn't know was a thing, is that there's valence and seq quarks. And the theory is that basically protons can have are supposed to be made up of 2 up and 1 down quark, But they found that they can actually have extra like quark antiquark pairs just chilling in the proton as well, right? Ready to swap in at any given time. And I think that when the mass of a proton is increased, it gets a higher flow rate. It is creating more of these C. It is able to create more of these C quarks, right? More of these C quarks. And when there's more of these C quarks, it can have more. It has more. Energy production capability, because it can swap in like a new and honestly it just makes sense in general. Like if you try and pluck one of the valence quarks out, like there's replacements ready to go. So that's why like the protons just kind of chill. But they create more of these C quarks, and these C quarks are helping with higher energy production. And I might have to look into this more because I'm starting to realize that I don't really understand how that will work. Because my initial theory thinking was that, well, if there's more C quarks, more interactions can happen and more switch outs can happen. But I don't necessarily understand why that would be more advantageous. The only thing I can think is that every time one gets swapped out, it's like then ejecting that swapped out particle or something along those lines, or the C, as it's creating C quarks, it is able to like basically send these C quarks out as energy for everything else. But I don't know if that's necessarily quite right. But I imagine that the proton does in fact get the capability to create more C quarks when there's more energy flowing through it, because it has a greater mass around it. Well, like increase in mass, increase energy flow, increase the amount of C quarks produced. Somehow that leads to a higher release of energy in what I would say is probably is like photons or something, that is then absorbed by the neutrons and the electrons in the system. But I'm not sure. I'm still a little fuzzy on that transition from C quarks to radiating photon energy. Maybe it's creating C's of up quarks, and it's creating C's of like C. It's creating C up quarks and it's creating C down quarks, and then those two are basically interacting. They cancel maybe, or they collide, create just photons. These photons are then sent out because of these collisions that are happening outside in the sea of the proton, I guess. And then if for some reason the valence quarks are interrupted and one is lost or something, one of the C quarks can just get subbed right in. So the proton's creating these C quarks as a backup for itself, but and then the rest are just getting sent out as it's creating it, because once it creates new C quarks, it's releasing, or it's destroying and releasing the energy of the old ones to make room for new ones and keep them as fresh as possible. And I laughed earlier because it made me kind of think of how, like, human beings, or just animals, most animals in general, right? Like, the males are constantly creating sperm, right? And so not all of the sperm that is created is used, right? But sometimes it is. So we, like, the sperm is basically, its purpose is to create new life. And so the proton basically has this sea of of quarks, right? And they are there to create, a new they're there to create new life, but really they're just like replacements for, like, a quark, in case something happens. And so it doesn't need to use all of them. So, just like in humans, not all of the sperm is constantly being used. So as it gets old, it gets broken down and then, like, scrapped for parts, basically. I'm not a biologist. I don't have a good idea of how that functionality works, but I'm pretty sure that's what happens. And I think that protons do something similar, except they have this excess energy, and since they're energy creators, they don't need to keep this excess energy around. So, or maybe they do, but they don't necessarily try and, like, send this energy out. But in these annihilations, some of that energy is being lost, and the more energy flow coming in, the more sea quarks being created, the more sea quarks being annihilated, the more energy is being released. And so as the mass of the proton increases, or I should really say, as the mass of the atom increases, the amount of excess energy being released by these annihilations and scrapping of, old parts, basically, is increasing as well, and is what is causing this formation of higher energy and more stuff going on. And yeah, so while I'm on it, I also wanted to say, going into this, I was watching videos and they kind of talked about how neutrons can decay and become protons, and then they said protons can decay and become neutrons. And I just kind of took that at face value, and I was like, oh, okay, they kind of interchange. But then I watched a video basically saying that protons don't really decay. We haven't observed it happening yet. And I thought that was interesting. I was like, okay, well, that kind of makes sense, though, because protons create energy. So why would they need to decay? They are their own balanced state. So, like, it kind of makes sense. And so, pretty much, we haven't observed protons decaying because they don't need to decay, because they're self-sustaining, like, particles. Protons do not need an electron to be at balance, right? They just produce their own energy. And as I was just saying, they're creating these seed quarks that are there to replace it if for some reason, like, one of its down or up quarks gets interrupted. Then it's creating replacements. So it's basically got its own regeneration system, right? So the proton doesn't decay because it doesn't need to. It's created a system where it replenishes itself and regenerates itself as needed. And increasing mass only just increases the amount of energy it can put out, but it still keeps itself at a balanced state. It's just that it's giving more access to other stuff, but it doesn't need to do that to stay at balance. Anyway, peace out.